Welcome to Hex Technology, and we're going to talk about relaxation passes and Startup Retorque. Are they worth every penny? So there's been a lot of questions within the industry for gasketed joints. When do we do a relaxation pass? When do we do a Startup Retorque? So I'm going to give you a little bit of history and what we found on the relaxation pass, and then kind of look at the Startup Retorque here in a bit. So the first thing I looked at was, what did Bickford say about relaxation passes? Because I think this is where it started. And he said you should determine these experimentally. And I think that's a really good idea with bolted flange joints. A lot of people have conspiracy theories, or they only do it on one application, and then they want to use that for all their applications. So with this, I think experimenting per types of application is a decent idea. That sounded great. And then as you see in the second one, he measured the A7 structural steel loss at 2 to 11% immediately after tightening, followed by another 3.6% in the next 21 days, another 2% over the next 11.4 years. Now that's structural steel, but I think this is a lot where we got that like 5 to 10% relaxation immediately after tightening. There's another part of this where the Southwest Research Institute suggests that fasteners lose an average of 5% of preload right after tightening because of what they call elastic recovery. Well, if you read further into this, they've got a 2 3/4 inch stud that's only got a grip length of 4.75 inches, which means that the length of the stud compared to the width of the stud, right? So call that grip length versus diameter, is really short. You want a 5-to-1 ratio, and that's not a 5-to-1 ratio. That's like a 2-to-1 ratio. So that's kind of, you would expect a lot of relaxation in something like that, especially when you're tensioning. So they're putting out 5% of preload because of elastic recovery, but what they don't really necessarily say is that's probably because the grip length is so small for this application. But we still just typically read that 5% and just move along with it. So what we did is we teamed up with a refinery here in the United States, and we want to see if there was what we called fake relaxation. Is there such thing as fake relaxation? So we took heat exchangers. That's primarily where they were focused to see their applications if they need to do a relaxation pass or Startup Retorque. So what we did is we got 6 different heat exchangers, and we installed the gaskets in them. 4 of them were cam profile. 1 was double jacketed, and 1 was a corrugated metal gasket. Fairly common gasket materials within the industry, especially now that everybody's moving to cam profiles. And what we did is we did UT measurements in order to measure the amount of bolt load loss at ambient temperature, right? So this is for the relaxation pass. So we took UT measurements once every hour for 8 hours, and then once a day for 6 days to complete a week, and then once a month for 2 months is what we were going to do. Well, and you can see here, these are the exchanges that we worked on. We did the modified star pattern. We also did the circular pattern on them to make sure, but we had really good bolt loads on everything we were doing, confirmed it with UT, and here's what we found, that we barely lost any bolt load. I mean, 0.08 for double jacketed, 0.5% for corrugated metal, and 0.8 for cam profiles. I apologize. 0.8 for double jacketed and cam profiles, and 0.5 for corrugated metal gaskets. And if you look, it just really didn't matter up here what we were going to like seeing any relaxation. And you also have to remember UT is plus or minus 3% accurate. So we were basically getting the same reading every day. So basically 0 bolt load loss from relaxation at ambient temperature. And we measured it every week, even before we got to the 2 months. And we noticed after 2 weeks, there was no relaxation. So we stopped the study. So relaxation passes on gasketed joints, as far as exchangers go, we can't see a need to do that unless you have a small grip length. Threaded tube sheets is probably where you might want to look into that one, where the middle of the nut to middle nut is really short distance. It's less than a 5-to-1 ratio of the grip length over the diameter. So that ended up being metallic gaskets. But I want you to note, this is not talking about sheet gaskets. That is a different topic. And do you have to do a relaxation pass on these? Absolutely, you do. So we turned to our friends at Teddit, and Teddit looked at the optimal retightening time for sheet gaskets. Vega, Carlos Giroux, and Igor all teamed up, and they got their test rig out. It's a 4-inch 300 blind flange. It meets ASME 16.5 standard, 8 bolts that are on there. They're all strain gauge, and they have their own software to measure this bolt load loss after they torque things up, right? So, yes, this is on a 4-inch 300, but we also see this on what they call the Amtech machine. And a lot of gasket manufacturers who manufacture sheet gaskets have got access to an Amtech machine and do this a lot. But this is the one that they wanted to do on an actual flange, because we asked them to do it on an actual flange and see what happens. So this was interesting. Here's what they said. They said they're going to torque this up, right, to 120 foot-pounds. Then they're going to wait a certain amount of time until they do a retorque, right? And this is the retorque right here. So the retorque, they were going to do at 24 hours, 4 hours, 1 hour, and 15 minutes. And then they were going to measure the relaxation after that retorque, right? And they would measure it, and at the end of 20 hours, report that number that happened out. Because typically you see relaxation happen pretty immediately, and then it kind of levels out. Still relaxes a little bit, but it levels out. So again, torque up to 120 foot-pounds, wait a certain amount of time, retorque, and then wait 20 hours and report the loss that happened. So the first gasket that they did was corrugated flexible graphite gasket. And what you see here is 17.1% bolt load loss or relaxation if you don't do a retorque. However, if you wait 15 minutes and do a retorque, you actually make up 6%. That's pretty significant. That's a decent amount, right? Just by waiting 15 minutes. And if you wait an hour, you only have 8.7, and then 4 hours, 7.8%, and 1 day, 6.7%. But the difference between, what I found interesting was the delta between 15 minutes and 1 day was 4.4% is what you can make up on there. Right? So 15 minutes is a really good way to get a good amount of relaxation made up. And then it kind of tapers off. You see where it like kind of platforms out a little bit right here? You still get a little bit of a load loss, but it's not as drastic. So that was interesting right there. I don't see a lot of those gaskets in with like petrochem. We typically deal with, on the refining side, metallic gaskets, but on the chemical side, they do see these. So really interesting on that one. EPTFE gaskets, same thing with no retorque, 12.6% relaxation, right? And after 1 day, 3%. So you made up another, 5.5% here. And then the delta between this and this is another 4.5%. So again, this one's 4.4, 4.5. So you can see here, you will get a little bit of relaxation after you do a retorque, after that 15-minute time frame. So there's no significant change in stress loss observed among 15 minutes, 1 hour, or 4 hours. So there wasn't really a lot of makeup on this, right? You're at 6% here, 1.5%. Okay, not a lot. That day, you made up a decent amount, 3% to 6%. Could be considered a decent amount. Depends upon your leak buffer, on how you're calculating your torque and your gasket stress and everything else in your flange. 3% in bolted flange joints, we consider torque plus or minus about 30%. So that 3% is a real small factor in what we do. So is it worth waiting 24 hours? That was a big question there. They also tested spiral wound gaskets for us, and you can see there that there's a 3%, almost 4%, and 2%. It's a 2% difference. So they confirmed that the spiral wound gaskets probably don't need to be have a retorque, because you're only going to lose a couple percent there. However, on their final graph, they did show that it does make a difference for sheet gaskets, the EPTFE, and possibly other sheet gaskets too that we didn't test in here, that 15 minutes is a good amount of time to make up a decent amount of this bolt load loss that you get with sheet gaskets. You can continue waiting, but what they found is, and this was really interesting, Other timestamps did not show such a significant improvement when compared to the 15-minute gain. So reducing dwell time means reducing plant downtime. So if you're looking at plant downtime and you go back up to here, is it worth making up a couple percent by waiting a full day? Do you have that time? If you do, then yeah, absolutely. You can go do a retorque after a day. If you're in the middle of a turnaround and you're trying to start up, you need to look at, does that 2 to 3% affect our gasket stress enough where it truly, truly matters? So that said, thank you, Tedit, for doing that for us. We thought that was really interesting on sheet gaskets. So that's the that's the relaxation pass part of this. So then we looked at Startup Retorque, and we see people do Startup Retorques kind of not necessarily arbitrarily, but they don't understand why and when and where it might happen. So we always say, but wait, there's more, right? Warren Brown and Zelim with Integrity Engineering Solutions down in Australia did a really, really, really good PvP paper, and it's called Quantifying Bolt Relaxation During High Temperature Operation. So what they looked at is they looked at several different materials. You can see up here B7, B16, and B8. Those are very common materials in the petrochem industry. And they looked at relaxation over 1,000 hours at 725 degrees Fahrenheit or 385 Celsius. And this was really interesting. Look at this B7 right here. It dropped almost 60% in that 1,000 hours at that 725 degrees. That is a lot of relaxation. However, the B16s only dropped about 20%. And if you look at the B8s, it actually gained load, right? So when they looked at this, they said, hey, the B7s lose 60%, the B16s lose 25%, and B8s lose 0%. So Warren's suggestion was that B7s, you might want to cut off, most people cut off their B7s or transition from B7s to B16s at about 800 Fahrenheit or at 7 to 750 Fahrenheit process temperature, right? He said you might want to get that closer to 650. That way your B16s come in and help you out with relaxation. You don't really get into this mess down here, right? So basically saying if you think that you're going to have a high amount of relaxation and that's going to affect your gasket stress, upgrading to B16 studs is a good way to eliminate that relaxation where you don't have to do that startup retorque. Because what we see is some people will put in the B7s to save money and then they come back and do the startup retorque in order to make up that bolt load, right? So jump back up here and then level out to where the B16s are. Why not just upgrade to the B16s and not have to do the startup retorque? Very good suggestion there. Also, one of the things that he said, which was really important as an assembler, I never cared if I put a heavy hex nut on a B16, but you really need to be putting grade 4 and grade 7 nuts on. And it's super important. And the reason why is that the heavy hex nuts have a higher amount of relaxation than the grade 4 or grade 7 nuts that are on the B16s. Makes total sense for that, right? So the moral of the story is when to do a startup retorque, you need to do a kind of an engineering analysis of that because you are putting somebody on a live flange. But I think the first step before you get there is to look at the bolt material and see if you can make up some of this relaxation with the bolt material to help you with your gasket buffer. If you're using Appendix O of PCC1 for bolt load calculations. That said, if you'd like more information, we're definitely there to help. We can help you figure out how to do startup retorques, when to do relaxation passes, but just want to give you a 20-minute overview of how where this data comes from, where the industry is starting to go. And again, if you need any information, please contact us at info@hextechnology.com. Thanks for your time, guys. Hope you're doing well.